Feature refinement to improve high-resolution image inpainting. Imagine you took a picture of a room and want to remove a piece of furniture. We can do this virtually. Recent state-of-the-art inpainting networks, like Llama, are able to convincingly remove objects from a scene. At first glance, the results look quite good, but upon closer inspection, we observe the infill is lacking coherent structure and fine detail. Our refinement technique is able to preserve global structure and improve the quality of infill. We accomplish this by first running a trained inpainting network on an image at low resolution, where we know the model performs well. We then feed in a high-resolution image through the same network. The results aren't quite as good due to lack of context when infilling a comparatively larger region. To improve the high-resolution infill, we will use the low-resolution prediction as a guide. We downsample the high-resolution prediction and compute an L1 loss between the two scales. We iteratively refine an intermediate feature map in the network to minimize this loss. This results in a high-resolution prediction that matches the structure of the low-resolution image while containing far more detail. Typically, Llama's high-resolution inpaint is blurry and gray when attempting to infill large regions at high resolution. With our refinement step, we get much better color and much sharper details. Structure and consistency is maintained across the infill region, and we get much more definitive results rather than an average of plausible infills. The infilled region is better harmonized with the rest of the image. Our refinement method outperforms all available inpainting networks when infilling medium and large masks. Thank you.